Hello, I'm here to tell you a few words about PyPy. So, well, let's start with what is Python. Python is great, everybody knows it probably. But people say that Python is just a glue language that we use to glue various parts together. And why don't we use Python left and right? Because Python is slow. So we have to write pieces in C, pieces in Fortran sometimes, and pieces in Python, and we glue them together using Python. And well, I claim there's citation needed. You can see why. It's Wikipedia professor. It's not entirely true. Somebody wrote a blog post recently where he compared PyPy with Node.js, which uses V8 as engine for running, on Project Euler, which is not a very good benchmark, but it's one of the best we can get for multiple languages. And PyPy scored 29 wins against 20 for V8. So it's not that slow, because everybody knows V8 is fast. It's done by Google, right? So Python is not necessarily slow. It can be slow, it can be fast. It all depends. So what is PyPy in short? PyPy is many things, but what you care about is Python is just another Python implementation. You use it by typing PyPy and then Python program and it just runs. And that's all you need to know for the purpose of this presentation. And it has few certain features, like it comes with a JIT compiler. JIT compiler means that you don't compile Python to say C or assembler. You instead run the interpreter, and when things get hot, which means they're executed often, you compile it just in time into assembler, knowing a few things at runtime you wouldn't know otherwise. It comes with stackless features that might be. How many of you ever use stackless or greenlands? Okay, only a few people. Anyway, it's kind of cool. It's not that useful for a lot of people. And also it's fast. Fast. What does it mean fast? So, this is a comparison of our benchmark set. It's our benchmark set, I'm saying up front. And it's all normalized to time that CPython 2.6 took, so this is 1. And less is better. So this is like probably 10% faster. This is slightly about twice faster. This one would be like 20 times probably. Yeah, or 25 maybe. So it all depends on the benchmark. And you can scroll here. So for this benchmark set, it's not given for all benchmark set. PyPy is quite a bit faster than CPython, somewhere between 20% and 30 times faster. It also evolved quite a bit over time. So this is the graph of Django benchmark, and it starts at, here's May 2010, I think. Here's May 2011. And this is CPython. So again, lower is better. We started about 3 times faster, now we are about 12 times faster. And decreases over time. So we work quite hard all the time. This is a year and a half, I think. So status. We, unlike CPython, we release quite often. 1.6 is, I believe, the 3rd release this year. And we plan to release 1.7 soon, or 1.6.1, depends. It was released in August, and it's compatible with Python 2.7.1. It doesn't implement Python 3 yet, although there are plans. It's pretty compatible. If we are incompatible, barring a few documented cases, it's a bug, so we'll fix it. Most programs work. Libraries like Twisted, Django, Pyramid, I think, Eventlet, a lot of this stuff just works on PyPy, while C extensions sometimes work, sometimes don't. We have a C API that helps with this a bit, but it's experimental in its alpha. It also contains NumPy, which is in progress. It hasn't been done yet, but it implements basic array operations. And NumPy is somewhere between 3 times faster and 300 times faster, depends on what you do. Sometimes really fast. And PyPy is pretty stable. You can use it in production. In fact, people like Quora moved completely to PyPy, their servers, because I think Quora scored like 2 times win over moving, just changing the interpreter from CPython to PyPy. What you can do, you can try using Python on your own programs. There's nothing preventing you from doing that. PyPy is just a free software. You can just go and take it. And if you complain about Python performance, there's nothing really that justifies not trying. It might not work, it might work, but it's worth trying. How many of you ever had performance problems with Python? Quite a few people. Sorry? Well, depends. And your program should not require changes. There are a few changes that you might not be aware of, like PyPy, like Jython, and like IronPython implements a real garbage collector. So, for example, if you don't close your file, it won't necessarily be closed immediately. So you're supposed to close your files, otherwise you might run out of file descriptors or things like this. You should not need to change much. Examples, because people always complain that it's all just stuff. So LWN wrote an article some time ago when they compared parsing of git log, some statistics, and CPython took 63 seconds, PyPy 21 seconds. I'm pretty sure that was like half a year ago or so. PyPy is now faster than that. And what they say is they say that it works and it's fast, and they didn't require any changes to their code base, which is also pretty good. Another example is MyHDL. It's a language for developing boards. So if you want to make a custom chipset, I know it's not your primary use case for Python, but for some people it's very important, and it's usually, yeah. Again.
Does it generate Python code runtime in a palette?
Yes. So the question was whether MyHDL generates Python from the specification. And yes, it takes the specification and compiles it to Python. And then you get Python that runs your chip emulation, essentially. So it's now competitive with actually used VHDL and variable simulators. For example, a place in South Africa that builds a telescope is considering moving all they have into MyHDL just because it's much more convenient to use. And now it's actually as fast as everything else. So what they said, you can go to the website, I'm sure they updated this, but this is a good case scenario. This is a place where you generate a simple Python that does a lot of numeric computations, and the results are 6 to 12 times faster than using CPython, and that bridges the gap between C and Python, essentially. So how can you help with PyPy? You can try it on your application. We want to know if it's slow. We want to know if it doesn't work, and we want to know if it's not slow and actually works. Also, we want to know that. You can tell other people. You can contribute. It's not that hard. It sounds hard, but it's actually not. What we have is we have a lot of separation of abstraction. So interpreter is here, garbage collector is there, just-in-time compiler is somewhere else, and you can contribute to all kinds of things. For example, there are students who are implementing just-in-time compiler backend for ARM phones or ARM devices in general, including phones. There's another student that creates PowerPC backend, and there are various people who do random stuff that's not necessarily connected, and that's the beauty of architecture, that you don't need to know C, unlike contributing to CPython. You actually have to know C, and that's a bit annoying because you're a Python programmer. But it's enough to know Python to contribute to PyPy. Or so we say. then you can donate. We just run a campaign for creating Python 3 interpreter within PyPy, a donation campaign, and we plan to launch very soon another proposal for implementing NumPy. And NumPy is a very obvious target. PyPy already performs really well on the numeric computations, and essentially bringing NumPy to bridge the gap between you might not need to use C or Fortran for most cases. Like, not all of them, but for most cases you might as well write loop in Python. I'll show you in a second. So there are cool things that I have. I'm not sure how many of them work actually. So this is an image processing algorithm. I'm not sure. Oh, you can see anything. Not much. Oh, great. This is an edge detection algorithm. So actually the original video looks like this, and well, it's a video. And then if you run this using a simple Python program, well, not that simple, but you get this. So you get edge detection, and this gets about 40 frames per second, so it's real-time processing. And let's run this using CPython for comparison. We're gonna have to wait for a thread for a bit. Wait. Wait some more. Okay, so we get 0.06 frames per second. That's about like, well, 100 times slower, something like that. No more, like 300 times slower. So this is a very good case where you have, here we go, where you get things that you couldn't do potentially with CPython because it wasn't possible to do real-time image processing, but now you can do this, and it's now pure Python. The program looks like this, and this is roughly the inner loop. And as you can see, writing this sort of stuff in C would be a bit annoying because you have to allocate all the arrays and everything, and they're not static; they're pretty dynamic. So you can write this stuff in Python and it actually works, and it's fast enough to do this sort of processing. And this is a good example because it uses Python level iterator over all the pixels. So image would be something like an actual class that has get item, set item, and things like this. This is much easier to prototype if you can write Python instead of C, because you can just write one algorithm using various classes that have custom access to attributes. In C, it would be just a total mess. Actually, those algorithms were implemented in C for application and comparison purposes, and they're like hundreds of lines copied and pasted and changed to use different things. So it's kind of hard. So this is real-time video processing. Software rendered games. So this is, well, it looks a bit silly. But this is a webcam processing image that's doing software level 3D on it. So we can look over webcam picture and it looks like this. Let's get closer. Okay, the webcam. And that's like real-time image processing and changing colors in Python. So again, a thing that gets like, I think about 10 frames per second using Python and gets like 0.0 something on CPython. And the thing is, this is just the beginning. things like having a fast Python interpreter open like a whole new world of things you can do in Python that you couldn't do before. Like you can go and have an entire class on algorithms at the university, or say numeric stuff that you just do using NumPy, and you don't have to worry about all this Fortran stuff or MPI or whatever. You can use high-level concepts to express low-level algorithms and still hope that it actually will work. I guess this is roughly it. I'm waiting for questions. Can you come here, because I don't think people will hear you. Okay.
Is the PyPy project cross-platform?
Answer.
Is PyPy project cross-platform?
Yes, as of now we support Windows, OS X, and Linux. With Windows 64-bit being somewhere but not getting really there. So 32-bit Windows and OS X and Linux will support 32 and 64-bit. And getting to ARM and PowerPC.
Will I see a port for Android?
What?
A port for Android.
If you write it.
El segundo que me mande a guardar.
Yes? Yes?
No, I think I said, every URL is checked with any written information about the system pattern that you will use
Sorry, I can't really hear you at all.
Okay, but, just wondering where's the documentation about the JIT compiler, how it deals with the fact that Python is dynamic and so I'm interested in JIT compiler.
Okay, so there's quite a big documentation on the website, the first one there on the list, and there are quite a few papers that we published about JIT compilers and writing JIT compilers. And not all of them are about Python interpreter, but about writing JIT compilers using PyPy as a toolchain for writing interpreters. I know there are people who use PyPy as a toolchain for writing interpreters that implement, say, PHP interpreter and something else. I'm not following completely those. But there are papers on that. And there's even, I think, I'm not sure if I can run it now, a Game Boy interpreter so that actually can run games that emulates processor and works pretty fast as well. Yeah.
What's the secret?
What's the what?
The secret that makes it so fast.
I guess if you look at the timeline, it's just 8 years of work. It's not like you It's pretty old. It was started in 2003, and I think by the first time I got to Python US in 2008, nobody believed me that it would actually be faster than they wanted, but it did at the end. So just patience.
I'm sorry I doubted you.
Sorry?
I'm sorry I doubted you.
So, but the question, how come CPython is older than PyPy and still it is not as fast as PyPy?
Well, CPython doesn't have a dynamic compilation, and actually having dynamic compilation in CPython is a major issue for a lot of reasons, like reference counting being completely all over the place in the interpreter source code. So it has been tried. One project was Cycle, the other project was on Lane and Swallow, and both of them didn't work because it's just too complex. And being written in C is a lot of issue. Python is a very big language. It doesn't look like it. It looks simple, but it's actually not. It takes a lot of effort to implement it because there are various building types and they all have semantics and everything like this. So It's just very hard to implement this for CPython as a dynamic compilation, not break things. Like C extensions, for example, are one hard thing that you need to break.
So the secret is that PyPy is written in Python.
Yes, that's one of the good parts.
And even though the majority is written in Python, you said...
Not all of it.
All of it, but you said the JIT compiles to assembly.
Yes, but it's written in Python.
Yeah.
I can show you.
I mean, the end product is pure Python too.
The what?
So how do the JIT assembly generated code interact with the byte code?
It's
Usually now.
a quite hard question, but it's generating for each byte code. It looks into interpreter, and instead of interpreting, it generates assembler for that. So, for example, this is how it looks like, say, somewhere, say, generate item. So this is the piece of JIT generator. So this is reading an item of an array. So it unpacks arguments like a normal Python tuple unpack, and then does address add, which is a normal Python function call, somewhere here. That returns a Python class that's address location, and then generates assembler on top of that. And actual assembler generator should look like this. This is x86 mov instruction between somewhere in heap and EPX, for example. This is what generates assembler. I can show you, I have extra slides. So this is the function, not a very complex one. I will make it font bigger. Okay, so this is a function that adds numbers, and I have a tool here. So this is the same function, and this is the bytecode of the function. So actually, you can see that the first part of the function didn't get compiled because it ran only once and compiled only the loop. So this is bytecode, load fast I, load cost 100, and then compare. And these two generated no code whatsoever, and those things are comparison on the assembler level. So I could even have a button somewhere. Show assembler. So this is an x86 comparison instruction between the register and the memory address and then jump. And this Python code, this precisely, got compiled to like 2 assembler instructions. Then you have I plus equals 1, it got compiled to, and again, 1 assembler instruction, which is equivalent to 1 intermediate operation. And then a bit of code, this is the code that cares about making Ctrl-C work. So you need to get an exception and not randomly abort program. So you check. It could potentially be done better, but I still think that like 8 assembler instructions per Python loop is not that bad.
Question related to this. I know how Iron Python was developed, and the fact that when they do the JIT compilation, that compiled code can be shared within the .NET VM. Do you have something similar where I've got a PyPy process that did a JIT compile to a piece of code, for example this one, and then I run another instance of PyPy and Array knows, oh, I already did a JIT compilation for this, I won't have to do that.
No, there's a major difference between the way Iron Python works. So Iron Python is implemented on top of a VM and compiles stuff to a VM. And CLR, or however the VM is called, actually says you can compile everything to a VM and be fast. So we decided no. We don't think it's a good way because languages are different, too different. So instead you write an interpreter and then you have a thing that takes an interpreter and generates a JIT compiler for that. So you end up having JIT directly emitting assembler from Python bytecode actually, but it might be Python source code. It doesn't matter that much. But you don't have a step where you have a common virtual machine that you
Okay,
run
so
everything.
there's no reuse of that JIT compilation within.
You can reuse JIT compilation, but you can't reuse a VM. So say object model will be different. If you implement say PHP in PyPy,
Yeah.
you implement PHP interpreter essentially, but you don't use the same VM. Your runtime is
Yeah, I'm
different.
asking more of if I'm doing a JIT compilation of a Python code, right, and the output is this. And now it's done by a process of PyPy doing one thing, and I got another process of PyPy and it has to do again that JIT compilation or not. That's my question.
Yes, that essentially has. Yes.
What difficulties do you see in order for PyPy to become the default Python?
What do you mean by default? Like, I don't think it will ever be reference implementation. Like people who care about language design are familiar with CPython. They will stay there. We deliberately said we don't care about language design. We just care about implementation. So PyPy is complex in many places, but it's you would rather have CPython still stay reference implementation and PyPy be used. And the things that can prevent it is like C extensions. For example, LXML doesn't work on PyPy or any other Python project actually. So this is actually a problem because a lot of people want to use that. It gradually will get there, but it will take time for libraries to adopt. But also things like it's sometimes hard to make a move because you actually have lots of Python running and you don't want to move because it's effort. Even if you're not super happy. So there's also inertia associated with that. But other than that, it's getting there at some point. Just will take time for a few years.
Which are the most common hiccups you will find when you're moving from CPython to PyPy?
I think the single most common is closing files. So people would write things like this. And then they expect stuff to be in file by now. And that's not true. In PyPy, the file wasn't closed by now. So instead you have to write things like and now you have stuff written to a file. So this is the reference counting difference, and this is the single most common difference. The other ones are obscure ones, like I'll show you one really obscure, and that's actually...
You said was related with C extensions.
Yeah, C extensions are problems on its own, but this is for Python code.
Yeah.
For C, I think NumPy is the most requested thing, because people really want PyPy to run their numeric code fast. But my favorite one is so what that would print? So that prints, among other things, this guy. So I will copy to a bigger font. So any clue what this is? The variable name underscore square bracket 1 square bracket. An idea. Yeah. That's at least being built. And guess what Django did? Django relied on exact naming of this variable. Not only that you have square brackets in there. So then broke some tests. So people rely on really obscure details sometimes. That's precisely because list comprehension is not a language feature and you have to build it somewhere. So you use a local variable named obscurely so you can access it really. So various things like this. Okay, I think we're good then. Thank you.